Section 6.6, Deductive Property Proofs. Okay. So indirect proofs. We are going to use indirect reasoning to complete a proof. To do so, we're going to assume the statement we wish to prove true is actually false. Then we will continue our reasoning until we reach a conclusion that contradicts something we know to be true, telling us that our assumption must be false. Okay, so for instance, if I said the sky is, I'm trying to prove the sky is blue, and I say, well, assume the sky is not blue, and then I go through my proof, and then I end up saying, well, dogs lay eggs, and we know that not to be true, so then my assumption is false. Maybe that's a poor example, but doesn't this sound fun? Yes, it does. Okay. So example, given this triangle, I say that angle 1 does not equal angle 2. And I say that AB, this length, is equal to AC. I need to prove that BX does not equal CX. And I'm going to prove by indirect reasoning. Okay? So first of all, I'm going to assume the opposite. I'm going to assume, hey, I'm going to assume they are equal. Okay? And I'm going to say, so AB is equal to AC. The reasoning, given. Okay, I said AB equals AC. That was one of my givens right here. Okay, then I'm going to say AX must be congruent to AX. Why? They're the same thing. Okay, so I have two sides that are the same. Then I have BX is equal to CX. Well, that was my assumption. Okay, so look, I have two sides that are all the same. So I can say that triangle ABX is equal to triangle ABC because of side, side, side. So because of that, angle 1, I'm going to go back there. Angle 1 is equal to angle 2 because these are congruent triangles. Okay, and that is because congruent or corresponding parts of congruent triangles are congruent. Okay, so, but this contradicts something I was given, something I know to be true. If it's given to you, you know it to be true. This contradicts, so therefore my assumption that BX is equal to CX is false, so BX is not equal to CX. This is not true. Okay, that's what that X there was for, even though it's not deleting for me. There we go. Okay, so I assumed the opposite, and then I went through my proof and I saw that I got a contradiction to something that I knew to be true, so then my assumption was false, thus proving. Okay, it takes a while to wrap your brain around this. Use an indirect proof to show that the square root of 2 is irrational. So I want to prove it's rational, so I'm going to assume, or it's irrational, so I'm going to assume it is rational. Okay, so if it's rational, I could write it as a number divided by another. That's a definition of irrational, two integers divided by one another. So where A and B are integers and share no factors. Okay, if they shared a factor, it would no longer be a true rational number. So for instance, if I have 4 over 2, that's not a rational number, that's just 2. Okay? Sorry guys, there we go. So therefore, I could multiply both sides by b, and then I could square both sides. So 2b squared is equal to a squared. So therefore, a squared is even. This is what we learned yesterday. If I can write it as 2 times an integer, it's even. Okay, so a must also be even. So I can write a as 2w. So then going back, a squared must equal to 4w squared. So I have b squared is equal to 4w squared, right? Because b squared is equal to, if a is equal to 2w, I just lost myself for a second. I know what I did wrong. I forgot to write 2b squared here. Where's my green? Right? Because if 2b squared equals a squared equals 4w. So 2b squared equals 4w squared, or b squared is equal to 2w squared. Okay. So b squared must be even because I can write it as 2w squared, and so is b. b must also be even. So a and b are both even and have a common factor of 2. Oh, wait a second. I said they couldn't have a common factor. So that means that my assumption must be false. A and B must have no common factors. Therefore, the assumption is false. Okay, so root 2 is not rational. It is irrational. Okay, you guys have a day to work on these problems. Make sure you try some of these on your own. You're constantly checking the answer book. You're looking at your departmental and you're looking at the types of questions that could be asked.